Hi, I'm Brian. So today I'm going to talk to you guys a little bit around some development and debugging techniques for .NET development in AWS. Now, one of the common questions that customers come to me with when I start talking to them about running .NET workloads in AWS is, I'm a Microsoft developer. Why on earth would I consider AWS? Microsoft have got their own cloud. Why would I not run it there if it's a Microsoft workload? And I want to show you guys today some of the benefits that you get when you start looking at running .NET workloads in AWS, how we can do it, how we can debug, and how we can operate. So there are three main sections I want to take you guys through today. First, I want to talk about ASP.NET and what web applications and ASP.NET web apps look like running them inside of AWS. Then we're going to go into a little bit of .NET in the serverless world. So we're going to talk to how .NET can be used in Lambda, and we can create sort of microservices and those kinds of architectures on serverless, still using .NET. And lastly, I want to talk to some of the stuff we do in logging and monitoring in .NET, and some of the tools that we've got that are specific to AWS, which can help you run those .NET workloads and gain some insight into what you're doing. So, where can I run .NET code in AWS? If I'm running full version of .NET, I can run that on Windows servers, on EC2 instances, or I can use Elastic Beanstalk. I can use Windows Server containers in ECS. So if I'm using container-based workloads for Windows, the Elastic Container Service is an option. If you're looking at running .NET Core, you can run it pretty much anywhere, because we can run Linux-compatible workloads more or less anywhere in the stack, and there's a whole bunch of benefits to that. We go from hourly billing down to per second, so that's always cool. So Windows and Linux servers in EC2, Beanstalk. We can use Fargate for containers, which means you can get away from managing your container hosts and just say run containers. So that's cool. And Lambda, of course, is where we can run .NET Core as well. And we'll go through some of that in a bit. Some of the reasons we talk to customers about why you would run your .NET apps in AWS as well. We have twice as many Windows Server instances to select from, so you can really right size where your stuff's going to run to. Which is moderately interesting, but I think there's more compelling points on this slide. We have double the number of regions with availability zones. Now this is a big one. All right, so if you're not familiar with it, each of our regions has always got 2 or more, so Sydney's got 3 availability zones. Each one has at least 1 data center in it. We're all tightly connected. Simon and Alicia talked to some of this in the keynote today. So that is a benefit as a developer because it means I can run a highly available workload within a region without having to worry about failing over to a different geography. AWS has had 7 times fewer downtime hours, and this was independently verified and published last year, so the stats are all out and about. So in terms of trusting a cloud provider to keep your application available, the data speaks to the fact that AWS has a brilliant track record based on our experience operating in the cloud. We've been running since 2006. We on average get 2 to 3 times better performance of Microsoft SQL Server on AWS servers of equivalent size compared to Azure. Again, this is data that's been independently verified and published. It came out late last year. And our customers that are looking at running SQL Server workloads are able to run on smaller instances, which means they can be more cost effective while still maintaining an appropriate level of performance. And lastly, we've got 5 times the number of service offerings around encryption to help maintain security of your applications. Again, Simon talked to this during the keynote around how easy it is to have ubiquitous encryption around your applications. Okay, so let's start with ASP.NET. Now, if you're an ASP.NET developer and you want to run in AWS, the developer tooling is pretty much wherever you've been developing previously. AWS has native extensions for Visual Studio and Visual Studio Code that enable a bunch of different development scenarios for how you want to do your .NET app development. So if I'm doing ASP.NET Core or if I'm doing full ASP.NET, we integrate with the tooling where you are now. We've got a lot of tools to help automate your release pipeline. So this is where code build can be used to help build your .NET apps. So we've got that in both Linux and Windows compatible build servers. So we can still do full versions of .NET for builds. Code pipeline helps automate the release steps. So to do a build, run some tests, release it to dev, wait for it to be approved, release it to test, that sort of thing. I would say go and watch the session at Summit on that one, but it's literally happening at the other side of this room as we speak, so catch the recording when we get them on YouTube. And code deploy helps automate releases into environments. So things like blue-green deployments, bring up new instances, drain the load balancer from one to the other, watch it for a few minutes, and then drain it back, kill the old instances off when they're done. So we give you a lot of tooling there that you can very easily integrate with around your AWS tools and services. So in terms of the SDK perspective, so if you want to interact with AWS services inside your app, so we have an AWS SDK for .NET. It is compatible with .NET Core, so there's no differences in the functionality between the .NET Core version and the public one. But we also add a number of helpers into the SDK to help automate some of that heavy lifting that's specific to .NET. So our S3 transfer utility helps make uploading large files into S3 with .NET easy. We have an S3 client-side encryption library. So if you want to handle encryption in your app before you even put it to S3, we help make that easier to do. The DynamoDB object persistence framework. So you can use DynamoDB to track state in your ASP.NET applications and have it store things there. Glacier Archive Transfer Manager for working in Glacier. We've got support for portable class libraries and Xamarin. So if you're doing mobile development across iOS and Android in .NET, if you're developing Xbox apps, you can go and use that portable class library to be able to run in there. And we also have a DynamoDB session state provider. So if you're using the native ASP.NET session state, you can point that provider at DynamoDB, and immediately it can get used to persist your session state instead of storing it locally in memory, which means suddenly I can use a load balancer that doesn't rely on session affinity or anything like that, and it frees you up from storing that on the devices. So rather than continue to talk to it, let me show you a little bit around how some of this works. Okay, so what I've got here is just a stock standard ASP.NET MVC app. Like I've gone new ASP MVC app and I've done very little to it. What I want to show though is how I'm able to use Amazon Cognito, which is our authentication service, to act as a sign-in provider. And I'm also talking to DynamoDB just to show what it's like to use some of our SDKs to interact with data sources. So to use Cognito in the first instance, so the app itself is quite straightforward. If I just copy the URL for it here. Come on, internet. There we go. All right, so I'm already signed in, but you can see it's loaded up a bunch of list of movies that's in a DynamoDB table. If I had cleared my cache, that one would have asked me to sign in with Cognito, so we'll go through and do that. In terms of enabling Cognito, we actually provide a native .NET provider for ASP.NET Core identity. So if you're already relying on that as a framework of authentication, we can use the Cognito libraries, so you don't need to make massive code changes to integrate with that. So all that we do to start with, so services.add Cognito identity, this brings the libraries into my app so I can rely on the Cognito objects, and it establishes an initial session state. So in my app settings.json, you can see here I've got all of the details like my app ID, my app secret, my user pool ID. So this is how it's connecting back to the specific Cognito identity pool that is going to manage my usernames and passwords and those sorts of things. Now, I've got a separate controller set up which is managing my authentication, so my user sign in, my password changes, those kinds of things. For the most part, it all behaves exactly the same. In fact, so if we zoom in on some of the code here, you see my sign-in, I'm actually using the stock standard ASP.NET sign-in manager to say sign in with a password. Now, because I've initialized Cognito, it knows that Cognito is my identity provider, and it's able to go through and do that against Cognito, so I can determine was there success or was there not. But Cognito also has a couple of different states to it in terms of responses that aren't supported in ASP.NET. So what we can do there is I can say, if it didn't succeed, and it is a Cognito result as opposed to just the stock standard result, I've then got the ability to go through and do things like, is it a password change or am I forcing a password reset? Some of those states that aren't native to ASP.NET. But that's the only Cognito specific code I've had to write here. Everything else about this, it just works and signs me in. Now, in terms of leveraging our SDKs, you'll see here I've imported the Amazon DynamoDB client. So the basic model for our services is you establish a client to the service. We can look in a number of different places for credentials. So if you're running on an EC2 instance, we can still pull those credentials dynamically based on the role of the instance, which is cool. But all I've got to do is start an asynchronous scan to get the objects out of my movies table here. And I tell it I want title, year, and info as the fields that it gets back. And it passes those down into my view to be rendered on the screen. Now, From a debugging perspective, this is just a .NET app. So I can run it up locally, it attaches the debugger. It's still remembered that I'm signed in, which is super, but let's just hit the local host from here. So you can see it's redirected me to my login URL as exactly as an ASP.NET app would do. So I give it my username and password for my Cognito user, and it signs me in. Right, from there we go, we talk to Dynamo, we pull some data down, I've got my identity. I'm now using Cognito as a persistent identity store in .NET with very, very little change to my code. Right, so that's a really great way to go about doing some of the stuff with ASP.NET. Outside of that, pretty much everything else you've always done about ASP.NET still applies, right? It's just a .NET web app. So there's not a lot else to that. So let's talk serverless, because this is where things start to change a little. Are you guys familiar with the term serverless when I say that at all? Yes? Cool. So just for anyone who hasn't really dived into it, serverless is essentially running code without running servers. Say I've got a chunk of code, just execute it. So we do that in a service called Lambda. We fire up micro VMs, and we build those per 100 milliseconds of execution time. Right? So you really are just paying for the time that your code is running. That makes it really great from a financial perspective, because if my code's not running, I'm not paying anything. But also, I don't need to worry about patching servers to keep them alive or anything like that. And the scale is managed for me, right? If my code gets called once, it'll run in one micro VM. If I call it 1,000 times at the same time, it'll spin up 1,000 of those micro VMs for me to execute my code and handle that. So auto scaling and that sort of stuff is just managed as part of the service. So .NET in the serverless world, we work with .NET Core here, so there's not an option to use full .NET in Lambda because Lambda is only supporting Linux-based runtimes. But I can bring, so we've got native support for .NET Core 2 and 2.1. We also have the ability through our custom runtime framework in Lambda to bring in .NET Core 3, and actually we've got native support for creating .NET Core 3 apps in our Visual Studio extension. So you can go in and say, I want a new serverless application based off the custom runtime framework, and then it's as simple as changing my project build from 2.1 to 3.0, and off you go. The caveat there at the moment, given that .NET Core is in preview, we suggest running with preview 5 or higher. So I think my environment I've been testing with 6 because there were some issues in the previous builds. Now, in terms of developer tooling, again, the Visual Studio Toolkit has some great support for getting your serverless functions started. We have the AWS Toolkit for Visual Studio Code. So that went generally available recently, and that again makes it easy to integrate testing and executing of Lambda functions from within VS Code. The last one I want to call out is the Serverless Application Model, SAM, CLI. So the SAM CLI is really great for being able to generate CloudFormation to deploy a Lambda function in any number of languages. .NET Core is one of the ones it supports, but it also gives you the ability to execute them locally. So we leverage Docker containers for that. So it will download a Docker container that has the current Lambda runtime with the same libraries, configurations, and everything, so that it can execute that in a local Docker container without you having to publish it to Lambda itself to be able to execute. So this opens up all sorts of doors for like integration testing scenarios and that kind of thing. So let me show you what some of that looks like. I'm going to stop my web app there. Okay, so what I've got here is I've just gone into Visual Studio and said, give me a new serverless Lambda, and done nothing else to it. Just want to show you what the default you get out of that looks like. So what it's providing me here with is a Lambda function that is going to respond to a call from API Gateway. So you can see there I've got my API Gateway proxy object. Lambda can be invoked from a few dozen different places in AWS, and we've got corresponding objects in the .NET SDK to help you strongly type where those JSON objects come out to, so you can more easily code to those. But in the case of being able to execute this, the Visual Studio tooling doesn't use the Docker containers. We've got a thing called the mock Lambda test tool. What this does is this essentially runs it in as a Lambda app in Windows. So it's worth noting that you'll be running in Windows here, not in a Linux-based runtime. But what I do get is the ability to attach a debugger. So if I want to run this locally, I can literally just go up here, press F5 to start my application. And what it's going to do is it's going to bring up a backend that will let me invoke through a web interface those Lambda functions. So you can see here I can simulate different AWS regions, I can simulate different types of objects, I can use different credentials. So again, this looks to my local credentials file, and it'll let me choose what credentials to simulate for the IAM role of that Lambda instance. So I can then choose a number of different ways that Lambda could be called to send some sample data in. It'll give me the JSON object here. But ultimately, I can just press execute function. Now you'll see my debugger has caught that because I'd set a breakpoint. So this way I can interact with Lambda locally to test my application logic. Now this isn't a full integration test obviously because the environment doesn't match where Lambda's actually going to run. But it's a really great way to make sure that your application flow is going the way that you think it should based on setting breakpoints and interrogating variables. So I'm just going to stop that one. Now, if I flick across to one that I've got done in Visual Studio Code. So this is an app that I provisioned out with the Serverless Application Model. So we can use the SAM CLI to literally just go SAM, new Serverless App, Framework, .NET Core, and it generates everything that's in here for me. So I get a source code directory, I get a test folder, I get the CloudFormation, and it's all ready to go and just run when I want to invoke it through SAM. Now, again, with just a little bit of a touch up here to the launch.json file that comes in Visual Studio Code for a project, I'm able to tell it that I would like to launch the .NET Lambda test tool. So this is the same tool that Visual Studio uses by default. You download it as an independent project, and you get exactly the same result. So again, I'm going to set a breakpoint here. Let's go there for argument's sake. And we'll go on launch. So again, it's going to spin that same backend up, and you'll see that same web interface for me to be able to go and execute and do my debugging. There you go. So I'm hitting my breakpoint, I'm debugging .NET running locally. But if you're more interested in that SAM stuff and actually executing locally in Docker, so I'm using the SAM CLI here to actually go and invoke that same function inside a Docker container. So SAM local invoke, the name of the function, so if I've got multiple functions in my project, it knows which one. I'm specifying no event in this case because I don't have a chunk of JSON to pass to it. But again, the SAM CLI will help you generate dummy JSON events that you can pass into your Lambda function to validate that logic based on like an API gateway call or whatever else. So I'm going to go and execute that. You can see it's pulling credentials from my local credentials file. Again, I've got the option to specify a profile if you want to simulate a different IAM role. But there, I see exactly the output that comes from Lambda. I can see the JSON object that got returned. I see details like the duration, the build execution time, the amount of RAM that was attached to it. So it simulates all of that in the Docker container for me. So my CloudFormation template, my CloudFormation template for this project specifies how much RAM was on that function, and it will then honor that when I spin that up in the Docker container. So that's a really great way, and we see customers automate integration tests under that same sort of approach. So I could go through and say, go and do SAM local invokes, check the output, and know that it has been run in a Linux runtime based off the same container that we use for .NET Core and Lambda to be able to validate that my function does what it needs to do. All right, so monitoring and logging for .NET. Now, there's a few things that we do in AWS that are unique services that we've put together to offer here around how you can go through and gain additional insights to what your applications are doing in AWS. So the first one is CloudWatch Application Insights for .NET and SQL Server. Now, this is cool because it's a really great way to get some specific insights to .NET apps and SQL Server apps based on machine learning models that you don't need to maintain. Right? You just point your log files and the data about your instances at this application, and we will tell you when we see things that don't look right based on .NET apps. We give you automatic dashboards, we give you mechanisms to notify on. The other one that we call out is AWS X-Ray. So what X-Ray is a tool for end-to-end tracing of requests within the AWS network. So think of this, where I've got a web application that calls out to a Lambda function. Actually, it calls out to an API gateway, which calls a Lambda function, which puts something in SQS, which then gets run by another Lambda function, which writes something in DynamoDB, and you're trying to performance troubleshoot that. Most of that is happening in an entirely serverless world that you've got no access to. X-Ray can generate service maps of these types of things, can show you success and failure rates of calls at any point in that stack, and can show you the overall time of execution at every point through that chain. So again, there's not a lot involved in terms of enabling the telemetry to say start capturing a request from here. So you'll have an initial entry point of a .NET app or like a .NET Lambda call as the first point of I'm capturing this request. And from there, it all feeds into X-Ray where you can capture the traces, visualize them, and really start doing some intelligent analysis of your applications. So again, back into demo world. Yep. Let's just close off some of these tabs. And let's have a look at X-Ray. Yep, let's shut that out too. So I've got X-Ray enabled in that app that we were looking at earlier, my ASP.NET web application. And you can see here it's generated an automatic service map saying that my clients come in and the first thing they talk to is my ECS container. Right, so my .NET web application in this case is running an ECS inside of a container. And from that container, I see calls that go out to Cognito for authentication, and I see calls that go out to my movies table in DynamoDB. Now, all that's involved to actually enable that type of integration, it's very, very simple. app.useXray, and I give it the name of the application. So this is the thing that's going to start capturing that telemetry for me. And after I've got that done, register X-Ray for all services. Now, if I'm only wanting X-Ray to capture specific services, I can say register for Dynamo, I can say register for SNS or whatever service you want. Here, I'm just saying capture everything. And because I've done it at the start of my application, everything throughout will go and do that. I could put that into individual controllers if I only want to capture specific methods. There's also a lot of things you can do to limit how much trace data do we actually provide to X-Ray. I might not want to capture every single request because it's going to be very, very verbose. I might say take 40% as a sample rate and send that into X-Ray. So it goes through and does that. To simulate the way X-Ray works if I'm doing local debugging, you can run it as a Windows service or as a standalone application if you're in Linux or you're in Mac. So that way, if I'm debugging locally, like I am here on my local host, it'll still send those details up into X-Ray. So I don't lose that functionality by not actually executing in AWS. In fact, you'll see when I come back in here and have a look at, if I click on the requests here and say I want to analyze traces, so it shows me over the last 30 minutes some of the requests that have come in, the responses, but you'll see all the URLs here are my local host URLs. So it shows me the requests that are coming in. We also see some interesting stuff down here around the performance time and things that are making it run slowly. And unfortunately, my inefficient scan for some reason hasn't turned up on the list here. But we can dive deeper into some of the requests. Look at trace lists. Let's go and find a trace for the home page. So I can see all the individual traces, the responses that came out, so the 200s and 302s. Let's look at one of the 200s. So you can see here, I'm provided a visual representation of that request. So I can see the request itself, the get user calls to Cognito, the get groups for user call to Cognito, the ludicrously inefficient scan of my DynamoDB table, so I can see, hey, that's what's causing that page to take a little bit longer to load. All that for just a couple of lines of code to say turn on X-Ray. Right, so that makes it really, really easy for me to start being very specific about my troubleshooting rather than shooting blindly and saying, oh, I think it's this, let's go and optimize it. I can make a data-based decision around where to spend my time in optimizing. Now, the other one is around application insights for .NET and SQL Server. So this is integrated into CloudWatch. So we begin here by creating a resource group in AWS. So I can say everything tagged with X is part of this resource group, which is a really great way to live if you're in the auto-scaling world and servers are appearing and disappearing. And create a dashboard from there. So what I'm able to do here is, here's where I would ordinarily see problems detected. Now, again, my app's pretty basic, there's not a lot wrong with it, but this will do things like look for long-running SQL connections. It'll do things like looking for inefficient memory use in .NET, and it starts making some recommendations to you specifically around things that you should go and look at as a developer. All of that's based off machine learning algorithms that we've been training to be able to make those recommendations to you. Just to show you some of the data points that we can collect in here. So if I dive deeper into my demo app here, you'll see I've got my one instance, and if I say manage monitoring, I tell it a little bit of detail around what am I running. Is this a mid-tier, like a worker application? Is it a front-end server? Is it a SQL database server? Again, this will just affect the types of recommendations that we look for. I tell it, this server's got IIS logs in this directory. I could say you've got application logs or SQL logs in another directory. So again, it knows the type of log and where they are stored, so it can bring those in and use those for recommendations. And which metrics do we care about? Again, I can tell it to make sure it grabs additional metrics from the instances so that I can do alarms on them in CloudWatch. Again, all of that, few clicks of the button, you've got it set up, and you start getting these active recommendations about how to improve the performance of your applications. So going through all that, we started with the question of, if I'm a Microsoft developer, why would I look at AWS? Why wouldn't you, right? Between, yes, the cool infrastructure stuff like the availability zones and all that, but the ability to run your .NET apps the way you want in all sorts of different formats, taking advantage of .NET Core to be able to run on Lambda, and some of the services like X-Ray and the CloudWatch insights that we've got there, it actually makes AWS a really compelling place to be able to run .NET applications, which is why we've got so many customers who are actively running very large-scale .NET apps on us today. So, in summary, I would say AWS is one of the best places you could run your ASP.NET web applications. The serverless platform really makes things interesting when you start looking at microservices and how you want to run in that world. And you can get deeper insight with the analytics that we provide through CloudWatch and X-Ray as to where your application is going wrong. So in terms of next steps, if you haven't already looked at it, go and download the SDK for .NET and have a bit of a play around with some code. We've got a developer portal for .NET. That's at the second link there to be able to go through and get access to training resources and examples. And lastly, if you haven't already got a free account to just play around with, go and sign up for one. Developers, we love getting hands-on and learning by doing. The free tier makes it really, really easy to explore running some .NET Core apps on Linux boxes for the first 12 months without incurring any cost. So it's a really great way to start exploring and learning some of those skills and putting that developer muscle to work. So thank you guys for listening. There's a couple of minutes left, but we're sort of wrapping up here at the moment. I'll be loitering around here for a few minutes. Otherwise, I'll be around the Ask an Architect booth the rest of the day. So if you've got questions or if you want to talk about anything particular you guys are doing, feel free to come on over, have a chat with me. Otherwise, enjoy the rest of Public Sector Summit. Thank you for coming.